Welcome to the Pac-Clone series of videos, The Race to the Finish, video 1 of 4. This video is of a technical nature and is intended for technically minded individuals who are interested in programming on the Commodore 64. In the previous video, I covered the release of the completed game, the Pac-Clone game, GPAC Dementia Defender, and I was very proud to get that out. And it's been out since February 25th, and I thank everyone for their support and their kind words that people have sent me via email and in the comments. In this video, I recorded the core content a couple of months ago. I'm covering the following: high score implementation, color code optimizations, animating the moving C on the title screen, how I implemented the title screen reverse character when you press F1, and the attract mode implementation. So that's what I'm going to be covering on this video in a few minutes. But before I get into that, I wanted to talk about the video I put out a couple of weeks ago, the Fantasy Art of Oliver Fry book giveaway. Now, unfortunately, it's been out for a few weeks and it's only got 41 views, and apparently so far no one sent me an email regarding taking me up on the offer to get a free copy of the book. I'm extending the offer out again. If anybody would be interested in picking up this fantastic book, send me an email to graydefender@outlook.com. graydefender@outlook.com. And in the US, I'll ship it to you for free, and if you are international, I'll split the shipping costs with you, just to get it into your hands. Before I go too much further, I wanted to give an update on the physical copies that have been distributed. I shipped 2 copies in the United States. The rest of them went out to international. I guess I have more interest in the game internationally. All of the games are spoken for. I have one person sitting on a waiting list now for the next batch. I am willing to create more copies of the game, but I do have to charge for that because I have to buy the boxes, print up the manuals, and all the copy and stuff. And then I have to ship them. So I'm charging $20. If anyone would like a physical copy of this game, send me an email over at graydefender@outlook.com, and I will be glad to put you on the list. Once I get up to 10 people on the list, I'll start shipping them out. Please go ahead and do that if you're interested. Going back to the GPAC Dementia Defender, after only being released for less than 2 days, the geniuses over at the Commodore Scene Database website, CSDB, have put out a cracked version of GPAC Dementia Defender, including a crack intro and a trainer, and it's pretty sweet and pretty amazing. I was really flattered when I heard about that. Somebody mentioned that in the comments on the video, and I sent off an email to Arthur Jordison, the guy who created CBM Prg Studio, and he wrote me back: "Hi Glenn, there are 2 sure signs you've been accepted by the CSDB mob. Your work appears on it, but you didn't upload it, and someone cracks it." Well done. And I also sent an email off was in contact with Mr. Sequel on Atari Age. And he wrote, "The crack tro represents serious props from the scene." And so yes, thank you guys for your support. That means a lot to me. I really appreciate it. So I wanted to show off the cracked version. Show you what that looks like here. So when it loads up, you see that little @ sign in the bottom right? I think it's doing a decompression. And so right after the pretty cool title screen shot, or the Batman laxity, and you hit the space and the great music that plays, there's a full-on trainer here, or this is the manual. It's just the actual manual from the game that I didn't put in the game. I put it as a PDF or as a printed manual. But this is the full, complete manual, with the exception of any screenshots that I had. And spacebar to exit that. And then it allows you to pick, in the trainer part, if you want unlimited packs, you want to be invincible, hit the control or the Commodore key to unlock the Easter egg, and then it shows the original cheat, T to skip a level. High score, mark with an asterisk. The high score mark with an asterisk is only, or what that's saying is it's kind of, it taints your high score, so that means you cheated. But technically, all of these, if any of these are set to yes, it should be an asterisk on the high score, so, but whatever. So the answer to these questions, yes, yes. And then if I just hit the Commodore key, it does my Easter egg unlock. And then if you play the game, and of course I started off on the fastest level here. But because I clicked yes, I'm invincible, so pretty cool that they were able to do that. What I was most impressed with was that the size of the program file was more than 10K smaller than my program, original program size. So they're at 24.5K, and my one that I have available for download is 34.7 kilobytes. So I think those guys over at the CSDB website, those guys are amazing, and they do some amazing work. So props to them for cracking the game, and I was very flattered. So this is video 1 of 4, and on the next couple of videos, 2, 3, and 4, I'm basically covering all the steps required to get me from where I left off in this video all the way to the finish line. And you'll want to stay tuned for that, especially I think the video on the sound and the music that I did for the game. So stay tuned for that, and let's get you into this week's video. In this video, I'm going to discuss the high score implementation. So when I was working on the design of the title screen here, I realized I wanted to have the high score up here, so I shifted down everything to make room for it. And then I realized I would like to have the high score actually display on the game while you're playing. And at this point I've decided I'm not going to save off the high score in a table of any kind. And well, anyway, I wanted to show how this was implemented. So what I did was I went back to the program where I had my scoring, and even though I've already covered this website, the Retro Remakes, this is where I got the score code from, I figured, I wonder if they did something with the high score. So I went back to that website, and it's a great website, by the way, the retroremakes.com, where he makes a game. And on step 24, I went ahead and downloaded it, and I extracted a piece of code, so I'm going to share that with you. And so all it is to check for the high score is a little piece of code, no more than this. And so what I did is I took the code that he had from step 24 and I adapted it a little bit. And so all it's doing is checking from the score from left to right and comparing the numbers. And let's take a look at this. When I execute this, in order to run this, in order for this to work, I need to throw some zeros out there. And so right now, when you execute the program, it's going to check to see if the score on the left is higher than the score on the right. If it is, or if it's equal, if it matches or if it's higher, then it throws a 1.
So it goes store a 1 at position 400, or if it's not higher, store a 0 at position 400. So if I make the high score on the right, these digits over here on the right would represent the high score. If I make that a little bit higher than the one on the left, and then I execute the program, there's no high score. If I come back up to my score and I make it, let's say, close to the high score, like 499, and then I run it, still no high score. And then if I make it equal to the high score or greater, well, let's start with equal, then it goes to a 1. So it works pretty brilliantly, and I was pleased with the code, because I was trying to think of how am I going to do that, because you can't just stuff this value in a variable and then say is variable A greater than variable B. Not with Commodore 64 assembly language. So you have to write a little program such as this, just a quick little loop. And then when I implemented it in the program, so that I just threw it down here to check for the high score. And right in this area, right after the program would have completed, I just did check for the high score. And then the way I wanted it to work was certain. I didn't want some of the code to execute unless there was a high score. So I have this as self-modifying, this is a self-modifying. So it doesn't update. I wanted it to automatically update the score as if you set a high score. I wanted to update both the score in the middle and the high score on the right as you're playing. But until you get a high score, there's no need to update it. So that's why this is kind of a self-modifying. And that's why I have this code here to self-modify those pieces. And let's take a look at that. It does no justice looking at the source code. So now I have the score and the high score on the right, and I threw these asterisks in hard-coded on the left and right here, just so I can up the score a little bit, and you can see my score. And I have the high score set at 10,000. So when I hit close to that 10,000, or as soon as I go above it, I have the self-modifying code which will activate and start increasing your score. Maybe I should have went with 1,000, huh? Okay, see how the score automatically increases. So anyway, that was how I implemented the high score feature. And so what I planned to do was just carry that score, whatever you finish is your high score, back over to the title screen. So I just plan to carry whatever your high score is, you put it up here, and then you have some options down here, which I haven't finalized, and then you hit the spacebar to play. And if you don't press a key after a certain point of time, a track screen will start. That's the plan anyhow. In this segment, I wanted to talk about a little bit of a code optimization that I did here recently, and that was to remove the color data from the actual source code. So with in CBM, you can set up all of your screens and how you want it laid out plus the color, and then you have the option of exporting your data, and it will group together how you want it, the screen and the color, all together or separately, and you end up with a dump like this. Like, here's the color data just for map 1, the color data for map 2, all the way down, and I had 7 maps right here. And I thought about it after a while, and I was like, this seems like such a colossal waste of program space. So what I decided to do was to eliminate that data, and the reason is most of the reason I could do that fairly easily is that most of the screens have one color or just a few colors. So I can just default like the walls to be one color, the dots to be another color, for example, on most of the screens. Now, there's a few problem childs, I guess, in like this one has a bunch of different colors, and I think this one has a bunch of different colors, and so they have to be handled a little bit differently. And what I decided to do to handle that was on the left side, I have here code 232 for this character, and on the right for this wall character I have code 230. So I decided to write a program that would check the wall character, assign it a color, and that was pretty much, let's take a look at it. That was pretty much it. And so let's go take a look at that. Now in the replacement source, when I've implemented this, so now here's the new screen data. And now it just has the screen information for the 7 maps, and the color information is gone. So there's only 7 of these and not 14. And then I wrote a program called character color, and what it does is as it's drawing the map, I call a subroutine to pick the color and then store it, and then I put it in various places. Now I thought this might take a hit on my transitions and when the screen draws, but really it does it so fast that it's not even noticeable. And so looking at the sub itself, it just checks. I put all the most important characters first, check the wall dot, set it to yellow. Check the wall map for map 1, set it to cyan, and so on. Check the cage color. And then I had to do a bunch of these for different maps, but it's really not that bad, And so adding this little routine saves those 7 maps from having to be put in. And let's take a look at it in running. I know it's not a big deal, but I haven't really done much optimization in the program. So you see how it displayed really quick? It's using that routine, and then when I go to another level, the transition, it draws the colors. So there's a couple of ways the screen's drawn, and you see it still works pretty seamless even with that routine having been added in. And so I'm really happy with the outcome, and it reduced the size of the program, and it's given me a little bit more breathing space. And so I just wanted to share that. Okay, in this segment I wanted to talk about an idea I had for the title screen was to animate the C right here on the GPAC. And it was just a simple idea just to show what it would look like if I were to close his mouth a little bit. And so I copied this screen and pasted it and then I pasted another version of it. And so I was thinking I would have this motion right here where it's just down, close, back, forth, and just have that go on the title screen. And it's a fairly simple thing to implement, and I wanted to show you that. So in the interrupt code, in order to implement this, you have to have some sort of a variable that detects whether or not the title screen is active. If it's active, then you need a counter, a sort of a delay counter, and that's what this flash counter is. And I have it set to 50, which is really slow, but once it gets to 50, then it executes this code here once. And then, so every time it hits 50, it executes this code once. And what this code is doing, it has another counter which keeps track of which position the mouth is: wide open, closed a little bit, all the way closed. And then it open
all the way closed, open, open all wide. I don't know if that makes sense, but, and so in order to implement that, there's 3 subs. One for all the way with the mouth all the way open, partially open, and then all the way wide. And I need to comment this and maybe even rename these subs. And I put them down at the bottom of the interrupt code here. So the one to open it up a little bit is, if to close the mouth just a little bit, so to go from this position here to this, all we have to do is fill in these spaces right here. So like, for example, I'm hovering over position 498, 497, 498, 499. That's what I'm doing right here at 497, 498, 499. I'm filling them in with a 160, which is that red character space, the blank space. And then I just filled in the rest of the characters. And on the third one, the wide, the all the way closed, we want to fill it in even more. So to go from this position to here, we want to fill in these characters. So at position 4BF, 4C0, 4C1. So that's what these are, 4BF, 4C0, 4C1. We want to fill those in, and that's what this is doing. So all I'm doing is just taking turn filling in, opening, closing, you know, filling in these positions. And then when you go back to wide open, all you're doing is erasing what was put in right here. So this was putting a 160 in, this was putting in a 160. Well, when you want to start over, instead you want to blank out those. So I'm loading in a characters 20, or which is decimal 32, a space, and then subbing into jump subroutine into this routine, but +2, so it skips the LDA, the load command for the for the 160. So it just puts spaces in all these areas, and then it does the same thing with sub 3, and skips the first 2 characters and just puts spaces there. And so all we're doing is stepping through that one at a time, and that's how I implemented that. So let's run the program and have it run slowly, and I'll show you how that looks. So I have it set with the 50 so you can see slowly how it oscillates. And to me that's too slow. I didn't want to close the mouth all the way. I didn't feel like going through that. But 50 is too slow. It's actually 5 times slower than I want it to go. And I'm thinking just setting it to 10 for the final implementation. But the lower you make that, the lower you make that variable, the faster it will oscillate. And I kind of like it right there at that speed. So anyhow, that's how I implemented that animation, and it's done during the interrupt code, so it's not running during regular program execution. Alright, in this segment I wanted to talk about, I wanted to show off a little bit of the early development of the title screen. I decided to change the text down here to say F1-options, and and let's take a look at that in action. What I've implemented so far. So as you can see, I have the animated C up there in the right, top right, and if I press the F1 button now, it cycles through the fruits. And I like this, and then I also all the way down to the backstory, so you can get to the backstory if you hit space, which I haven't implemented yet. But I like this option here, or this method. I wanted to somehow highlight the text when you push F1 in addition to changing the fruit. And it was done very simply, very simple to reverse those colors. And go into that right now. In the character set, the reverse, so the reverse is just 128 off. So 129 here for the reverse, and 1. So really all you have to do is flip bit 8. If you flip bit 8 on the character, you'll get the reverse of that character. And that's what I did in here in my title screen program right here. I jump sub to do a title screen color effect when the F1 button is pressed. And that's right here. And what that's doing is it has a sub, and it's ORing, or a 128. So it's doing a loop for 10 characters, and it's just flipping the bits. And then there's a delay in between that. So that's all you have to do to produce that effect. Now, the interesting thing is, I haven't fully implemented when you hit the space yet, but I did make a first attempt. So on level 1 here, when you hit space, it's going to start the game. And what you see is I forgot to disable this part of the interrupt up there on the top right. And oops, I know that's going to be loud. And so I just thought that was interesting. And man, if I had more time, I would consider using something like this as a challenge in a challenge format. But I like the concept of the doors or a passageway opening or something like that. I think that could be useful for a game like this. But anyhow, all that is I forgot to flip a switch here to turn that off. And let's see, I turned it on up here. Load a 1, make the title screen active. So let's see if turning it off, let's see if I could be successful by turning that off down here, except turning it to a 0. And that should fix that problem. So I'm going to hit the space bar, and now it's no longer moving up on the top right. So this is a simple fix for that, and I thought it could maybe ignite some creative juices, but I'm pretty much almost done with this program, so I don't want to go off on a tangent and start creating new challenge screens at this point. And then one other thing I'd like to point out, I'm still early in the development of this section. If you were to comment out these 3 lines of code here, 3 or 4 lines of code right here, then when you start the game, it doesn't pick the map, the proper map to start. And so this is actually quite interesting. Check this out. So now when you hit the space bar, you just start right in the middle. You're just moving around, and you can actually play the game on the title screen, which is weird. Now it will let you eat, if I could get back down there, it will let you eat the asterisks, and then you can eat the ghosts, but the ghosts don't really have a ghost cage. And so there's problems like that. And it resets them back where it thinks is the ghost cage. And start going down and run away. Oh, you can eat the dots too. Look at that. And boom. See, look, it goes right back to the ghost cage. Any way it can get there. It doesn't have to worry about the walls. And yeah, the scoring isn't working up there at the top. So anyway, this is just an anomaly, but I thought it was funny. In the function keys, once you start, you can't hit space or F1 or anything, but you just play regular. And there's no going on to the next level either, because that's not in place. But I thought that was interesting, and I just wanted to share that. Okay, in this segment I wanted to talk about the attract mode implementation for just a little bit. I've jumped ahead in the source code from roughly a Pac 30 to Pac 31 or so to Pac 37. Most of the changes in those versions were just optimization attempts and trying to make the code a little tighter. I succeeded in some, failed in others, but there was no further movement in the program until we get to Pac 37. And on this version, I have implemented on the title screen, if you wait long enough while the C here is chomping, after the C chomps for a little bit, it will automatically go into the attract mode, and it randomly selects a map. And I decided to have it also select through the challenge maps, so those could be watched. And the way I decided to implement the attract mode was to have it run until Pac-Clone dies. So it doesn't just run for a certain number of moves, but it runs until he gets eaten by a ghost. And what I've also decided to do, I haven't implemented here, but I'm going to have the high score set lower or to 0. Just leave the high score as 0. And if you leave the game running overnight, or if you put it in warp mode in emulation, even the attract mode will generate a high score that you can try to compete against. And I'm going to run it here in warp mode to speed it up. Oops. So you see it jumps through all the different maps, and it randomly selects between all the different maps. And I've had it run before overnight in warp mode, and depending upon which version or the scoring and everything, I've had it get pretty good scores, like 18,000 and stuff like that, which is amazing because it picks a fruit screen or one of the challenge maps, and it eats the high value fruits, and it can get a lot of points. Now there are a few problems associated with having the attract mode running. Right now I don't have a way of interrupting the attract mode. So if I wanted to right now go back to the title screen and play the game, there is no way of doing that in this particular version. And so I have to warp it. And now also, if you press F1, I had to reset the counter, the attract mode counter, so that it won't go into attract mode so quickly. It resets it. And so here on the title screen, you can hit F1 to select between the different levels, if I haven't demonstrated that before. And so if I pick the hardest level I have right now is I don't even know what fruit what that's called, but that little guy. And if I hit space, if I hit space fast enough, it will start that map. Let's go back to it. And so that's right now, that's where it's keyed to go. And so then also, I don't have a game end. I don't have a game end button or anything that will end the game. And then when my game ends, I haven't implemented it yet to go back to the title screen, because in the early development I didn't have a title screen, so I just had it die when you got to your last man. Looking at the source code, since it's up right here. Hold on. Just gonna move this aside. Looking at the source code, since I have it up right here, what I'm doing is I have a counter, turn on the attract mode counter. When it hits 60, when that happens, it turns on the attract mode. This variable is incremented in the interrupt. And why I put it in the interrupt was because I wanted it to increment based on how many times that big C chomps up and down. And so I wanted to be based off of that. And so if you increase this number, it will take longer for the attract mode to start. So here, let's go back into it. And the other challenge that you have that I noticed with the attract mode, or with this random selection for attract mode, is that I'm going to warp this. When you start this game, it tries to do a random number initialization. And so let's look at that. When you start the game, if you don't do anything, that's why I had that, oops, that's why I had, you notice right here I have it delaying until you hit the space bar. That was so that it would pick something more random. And I forgot to comment that out. Let's go look at that. So right here I just had it loop. I'm going to comment this out. Loops until you push the keyboard. If you don't have some sort of delay or something in between, then it sort of lacks proper randomization. And I don't know if there really is true randomness on a Commodore 64, but it's at least more random if you have some sort of a delay in there. So I'm going to hit warp. So now it starts on the Chaos Fruit grab screen. Notice the score he gets. He's doing good. Oops. Oh, I didn't notice that. I didn't know I went too fast. But then the next screen, notice it's this blue map. The third screen is a purple map, right? So if we do the same thing, we start over, I close the window and I rerun the program. Same thing. Chaos Fruit grab. Blue screen. Purple map. So you see there, it's like you just powered on your Commodore 64. There's nothing random at that point. And maybe I don't know the proper way of doing it, but for this reason I have decided that I was going to do a pre-introduction screen. And I'll and in lieu of that, I'll demo that here shortly, but in lieu of that, all I did was to add a little bit of randomness, do a little loop here, and so that kind of helps the program appear to be more random when you start the game. So now when you start it, it won't necessarily start on the Chaos Fruit grab map. See, now it's waiting for a key to be pressed, and then when it starts the attract mode, see, now here it started purple first, and then the next one goes to the Dragon's Wrath screen. So that's why I went ahead and developed a pre-introduction screen, which I'll show up here in a upcoming segment.